Hello, I am Mrs. Edwards and we're back. It is time to do math and I love it. Today we get to find the derivative of logarithms, and this process is really pretty straightforward. So if you have a log, every logarithm has a base number, and then you're finding the log of something. And so whatever that something is you're finding the log of, that is known as the argument. So if you take the derivative of log, base and number of the argument, all you need to do is put the argument in the denominator, the derivative of the argument in the numerator, and then you also need to multiply the argument that's sitting in the denominator by the number natural log of the base, okay, ln of the base. Okay, so let's just apply that. The derivative of ln x. So there's my log, there's my argument. Now I don't see the base number, but hopefully you remember the base number, anytime you have a natural log, that is base e. The number 2.71, etc. In irrational number, decimal goes on forever. So using that, the arguments in the denominator, x, the derivative of x in the numerator, and then we also multiply the denominator there by the natural log of the base number, ln of the base. ln, and the base happens to be e. Now this is a property. The natural log of e equals 1. And I'm going to put with your assignment a secondary link to a couple of log properties. It's a short video that you may want to watch just to review a couple of the log properties where you will hopefully understand why ln base e of e to the first power equals 1. But nonetheless, you must know that natural log of e equals 1 without a calculator. And then the derivative of x is 1. Right, simplifying a little bit more, and the answer is 1 over x. Okay, next, the derivative of natural log of 5x plus 1. So there's my log, there's my argument, and then the base that is invisible on a logarithm is base e. So the argument goes in the bottom, derivative of the argument in the numerator, and then natural log of the base number there in the denominator as well. Okay, ln of e equals 1, and then derivative of 5x plus 1 is just 5. Simplifying a tiny more, and there we have our derivative. Okay, next, derivative derivative of the log of x. Okay, there's my log, there's my argument. Now, whenever the base is invisible on an log logarithm, the base number we don't see is 10. Okay, it's kind of like when you have a square root, right? The square root of x. You don't see the little index number 2 when it's a square root. But if you want a cube root, a fourth root, and so on, then you've got to put in the little index of 3, 4, and so forth. So logarithm, kind of the same way, log. When you don't see the base, it's automatically 10. So let's throw the argument there in the denominator, the derivative of the argument in the numerator, and then natural log of the base number in the denominator, so ln of 10. The derivative of x is 1, and that is our final answer. Be very, very careful when you're dealing with logarithms, because if you wrote the denominator out as ln 10x, the 10 next to the x is multiplication, and that attaches it to the 10, and so then that would be ln of 10x. And ln of 10x is not equivalent to x multiplied by ln of 10. So if you did happen to put the x on the other side of ln 10 in the denominator, you would have to have a set of parentheses around each. If I leave it like it is right now, I could write just plain x ln 10, and that would be okay, right? But Be careful, right? Trig functions, logarithms. I think of them like a brick, like a brick from a house. You cannot change them. There's no such thing as distributing something through. It's a brick. It doesn't change unless you apply a property. Okay, enough said with that one. Last one, the log of 5x plus 1, and we have a base 2. So log base 2 of 5x plus 1. We're going to put the argument in the denominator. So 5x plus 1 in the denominator, the derivative of the argument in the numerator, so derivative of 5x plus 1. And then in the denominator, we're also going to multiply that argument by the natural log of the base number, so ln of 2. The derivative of the numerator is just 5, and that is our final answer. If you want to distribute ln 2, you could, but I don't think that's more simplified. That would make the denominator 5x ln 2 plus ln 2. You'd still have to be very careful with how you write it, because ln 2 multiplied by 5x is absolutely not the natural log of 10x. Okay, so when you go to do the homework tonight, you will be finding derivatives of logarithms, but they will be mixed together with your other derivative rules, like the chain rule, the quotient rule, the product rule, the power rule. But here's our new rule, and maybe watch the extra little link that I put there in Canvas for a couple log properties. Okay, I will see you next time.